So yeah, my name is David Hozza from Penn State University. I teach, I'm a lecturer in the Cybersecurity and Information Science and Technology area, part of the College of Information Sciences and Technologies. So here's a little bio about myself. Been a faculty member since 2017. Prior to that, I worked for over 30 years in industry in both financial services and for 17 years, and prior to that in healthcare information systems. So my focus at Penn State is teaching basically cyber defense and information science courses. Like I said, the idea for this exercise came out of a course where we teach an overview of information security to students. So the audience is it is a collection of students who in their past have possibly not had a really, a lot of programming and a lot of cybersecurity. So this may be their first introduction to encryption and things like that. I've also worked on developing a couple of cyber courses and probably over about 18 cyber labs, the traditional cyber labs where we use the virtual machines to achieve different objectives with tools like Kali, Metasploit, Nmap, things that a lot of you are probably familiar with. So if I'm going to frame the problem here, the problem I was having was it was tough for students to learn encryption. They were being overwhelmed, and a lot of times if you've tried to teach encryption, we have these slides that deal with, Alice and Bob and the private and public key pairs, especially when we're trying to explain asymmetric cryptography. And I saw there was a need for, more in the way of a hands-on application to learning the encryption algorithms, how they work, how the key pairs work together. And then when we add digital signatures to ensure non-repudiation, it gets really, really complicated. The way that I was delivering it and some of my colleagues were through traditional hands-on labs, but in that regard, we were using, things like SSL, PKI, SSH to demonstrate it. But at the end of the day, students were still having trouble grasping what's actually kind of going on behind the scenes. And then the last thing try to do is just try to make it a fun, more of a fun exercise. So, so what is CyberChef? So CyberChef, as some of you may already know, is a popular set of crypto tools, often referred to as the cyber Swiss Army knife. And it's maintained by the British government communication headquarters. And there's a link to it in this presentation. So it has a lot of uses. We're actually going to go through the lesson here during this presentation. It really shouldn't take long. So this is the actual lesson that I came up with, and it's gone over very well with students. So there are other uses for it. It can do a lot of encoding. We're gonna take a look at it for doing encryption and digital signing messages. It can do malware analysis, hashing, forensics, and a lot more. So we'll take a look at that. We use this tool for our students when they're doing CTFs and cyber competitions, but I never really thought about it before as using it as a teaching tool in a lesson. So let's take a look at the assignment. So I was having some technical difficulties with the screen share. I was hoping to share the assignment on one side of the screen and the CyberChef on the other, but I can only share the presentation screen. So what I'm going to do right now is I'll go through the assignment and just talk about it, and then we'll actually go ahead and do it. So I've already talked about the purpose. This is to reinforce asymmetric encryption, and we're going to use PGP for the encryption and the digital signing of the message. Okay, so one note here. The instructor needs to provide students with the instructor's public key, all right, so that students can actually encrypt the first set of messages. And then the deliverable was the student will submit 3 text files as outlined in the instructions. So the first part of the setup is that the student is going to go in and generate a PGP key. So I think what I'm going to do at this point is I'm going to switch over to the CyberChef tool. So I'm going to change my screen sharing. And then Josh, if you're out there, how do you want to handle the Q&A? Any Q&A?
Either I guess people can unmute and ask, or they can drop it in the chat and I can read it off to you. Whatever works best for you.
Okay, yeah, if we could do the chat option, that would probably work better, and then I'll just pause from time to time to see if there's any questions. Okay. All right, so I'm going to switch over to sharing the actual CyberChef right now. Okay, so everyone should be able to see the CyberChef. Okay. All right. So this is CyberChef. When you go to the link, this is what you're going to see. Just a quick overview if you haven't used the tool before. You've got the, you've got all sorts of encoding options. Some of the more favorite ones are sorted at the top here. So you can see we can do to and from base 64. We can do hex operations. We can do hashing operations as well. The other thing that's nice about this is if you have a hash and you're not sure how it was hashed, you can actually run it through here and it'll analyze it and give you some options as to what the hashing algorithm was that was used.
Hey, David.
So, yes.
Could you drop the link in the chat, please?
Sure.
CyberChef. Thank you.
Yeah. Just give me 1 second here. Yeah, the link is also in the slides, slide deck, but let me get it in the chat. Okay, so it's in the chat, and it'd be great if you could follow along. So this is the exercise that students did. I developed this last year, and it went over really well with students. Okay, so and it would be easier if you do have access to the slides to follow along. So the first thing you need to do as the instructor, well, first thing we're going to do is we're going to search on PGP because we're going to focus on PGP encryption. I just thought that would be the easiest for students to understand. Now what I'm going to do is I'm going to generate a PGP pair, and the way CyberChef works, and it, they're a little funny in the way they talk about, the chef and the baking and things like that. So everything is considered a recipe. So generating the key pairs is what they consider a recipe. It's, think of it as an algorithm, and you can actually stack these recipes in here. So if you wanted to run some data through one algorithm, then run it through another algorithm, it can do that kind of stuff as well. So the first step here for the instructor would be for them to actually generate their own keys. All right, so you can see it's pretty basic. It's generating a set of keys here. And then what I'm going to do is I'm going to save those keys, and I'll call it something like instructor keys. Okay, I'm going to put a TXT extension on those. All right, and I'm going to create a on my other desktop. I'm actually just going to create an area to save this stuff off. So let me copy the keys over there. And the other thing you're going to need to do is once you have that key file, you're going to need to give the students your public key. So what you can do is you can just copy this part out, here and then send them create a file and send it as part of the assignment. Because they are going to need your public key in order to do the encryption. You obviously do not want to give them your private key. And that's part of the lesson here. All right, so let me just save that off myself. Okay, so that's the setup work that the instructor has to do. And now we can go back to what the student's going to do. So one of the things I emphasize in the exercise, and you'll see it in the slides, is when you're finished, make sure you clear all the output. Don't just clear the recipe. Try to clear everything out of there, because you don't want extraneous input being stuck here when you're trying to do one of the other parts of the exercise. Okay, so now we'll get to the part one, where the student's going to actually do their work. So the student's going to have to do the same thing. So the student now is going to generate their own key pair, okay, because they're going to need the key pair to do their actual work. So this is what the student would be doing. So they're going to be saving student keys off. All right, and getting that out of the way. And I'm just going to move that into my other folder, which you can't see on this screen. Okay, so the student has done that part of it. And you can see we could save keys by saving them by disk or just copy pasting. All right, so we're going to clear all our inputs with the trash can. And the first task they're actually going to do is encrypt a message and send it to the instructor as part of the assignment. So they're going to pull over the PGP encrypt recipe. And now in this case, they have to think about how asymmetric encryption works. So they're going to need, in order to encrypt a message to the instructor, they're going to need to use the public key of the instructor, because it's one operation undoes the other. So in this case, they encrypt it with my public key, and then I can decrypt it with my private key. So when I would grade this, I would apply my private key to the decryption recipe and then decrypt it. So what I'm basically going to do is I'm going to slide my public key in here. All right, and one of the things you can do is you can actually, let me just make sure this went over okay. You can actually slide your file in, or you could do a copy and paste. And let me just double check. All right, so we definitely have, you can see this part here didn't turn green, so we have some sort of message. We might have an issue in our with our key. So let me just go back and clear this out. Make sure I've got the right key here. And it just doesn't like that key for some reason. All right, let me try this one more time. I'm going to clear that key. Okay. All right, that first key I copied, you have to be careful. I had a character that was stripped out of that. Okay, so they've gotten my public key, which they got from the assignment, and now they applied it. So this would be the first encrypted message that they're going to send to the instructor. So what they're simply going to do here is just save their output. Okay. And we'll just call it student task 1. Try to spell it correctly. .txt. So they would submit this encrypted message to the instructor. And I'm just going to save this as well, so we can come back and take a look at it later. Okay, so just checking the instructions, that should have taken care of task number 1. So why don't we pause here and see if there's any messages or anything in the chat. Okay, so delete the end public key and beginning info. And there's just so Josh, is there anything I need to address? I see there's a couple messages to you.
One just came in.
Okay, yeah, that's a good question. Do you suggest running such exercises in follow-along synchronous session? So I've actually done it. I've done it actually 3 different ways. So I've taught this last semester synchronously, and I did do it in, I did do a follow-along synchronous session, and that went over really well. You do have to pause from time to time because you're going to have students are going to get stuck at certain spots, but that went over well. And I actually just did it this week in our overview of information security class synchronously. Now, I also teach an online class. So what I did for that class was I did it kind of an introductory video to CyberChef, and walk through, I didn't walk through every step, but I walked through an overview of CyberChef, which gave them a good, an idea, having not seen it before, how it works, how do you slide the recipes over, and and that went over very well as well. So, so yeah, I would suggest trying to do it synchronously, and if you do have an online class, put together a video, a little bit of video help that could walk them through it. Okay. All right, so I think we can move on here. So we'll move on to what we consider here task number 2. So now what they have to do is ensure non-repudiation. Okay, so they're going to digitally sign and encrypt a secret message. So we're going to use the PGP encryption and sign recipe now. And also, I just want to emphasize, kind of make sure you're always clearing out any previous work. Okay, so now what they need to do is they need to put their private key. Okay, they need to sign this with their private key, and then they need to again put the public key of the recipient, who in this case is going to be the instructor. Okay, so let's see if we've got the student keys. So I'm going to open the student keys file that I copied earlier. All right, and I'm just going to take only the private key part out of that. And I'm going to paste it in here. And then I'm going to take my instructor key, which the student should have. Instructor public key, and copy it in there. And then we're going to have a message, something to the effect of, okay. And that's really all there is to it. So one of the ways that students get a little confused here is they're putting the wrong keys in the wrong spots. So this helps to reinforce the idea that if I'm going to sign a message, I am going to sign that message with my private key to ensure non-repudiation, so that you know that message came from me. And then on the encryption side, what I'm going to do is I'm going to encrypt that message with the public key of the recipient, which in this case is the instructor. Okay, so now they've got their second message, their second task complete. So what we're going to do in this case is the student would save this to a file. I'll call it student task 2.txt. All right, and move this into, just save this off. Okay, and then, you know, the last part of the challenge just asks the student, okay, what other file do you need to send the instructor? The instructor needs another file from the student that isn't necessarily part of the first two tasks that we did, but it was part of the setup. So I don't really give them a lot of information on that one, but I do caution them that they have to make sure they send us the right keys, and if they send us too many keys, that they won't get credit for that question. So I guess I would throw this out to the forum to see if anybody wants to chime in and say what key on the student part do they need to send to the instructor. Okay, I'll give it a few more seconds here. Okay, well, anyway, in this case, the student would need to send their public key, okay? Because the instructor, in order to undo the encryption done by their private key, the instructor is going to need the student's public key, okay? All right, so that would be it for what the student is going to submit. And at this point, I'll kind of walk you through how this gets graded. And I'll just pause. Let's see if there's any questions. Yeah, okay, so we've got a couple people that yeah, that's a good point too. Somebody mentioned, I would hope that students would recognize the peril of anybody asking for their private key. You would think so. Yeah, occasionally we do have a student who, because the first task creates a public and a private key pair, students just send that whole file over, and then, you know, that's where they run into trouble. So they need to parse out the public key part and just send the public key to us. So basically, then the grading works, you know, pretty simply. We just undo what we just did. So I'll bring over the verification part here. So the first thing we're going to do is we're going to, as an instructor, we're going to decrypt the message. Okay, so in order to do that, I will, I'm actually going to open the message here that the student sent us. Let me get to my the right spot here. Okay, so this was the message that the student sent in task number 1. Okay, and what I need to do now as an instructor is I need to put in my private key. So I'll just bring that over quick. All right, so you can see the student did it properly. So we got the output of test message from student. Now, one of the things I am working on to make the grading a little easier is I'm going to try to write a script to actually automate this so I can just read the files. We'll have to make sure the students name the file, you know, put their name in the file, but it would be pretty cool to automate this, the grading task on this, to just run it through a script instead of having to slide this. Fortunately, I have learning assistants that help with a lot of the grading. So anyway, so task number 1 is complete by the student. So we clear everything out. And then what we want to do is decrypt and verify side of this. So what I'll do first is I will just bring over the student's task 2 part, okay, as our input. And then what we're going to need is, I'm going to need the student's public key like we talked about. So let me just bring that over. All right, and then I'm going to need my private key to open it up. And hopefully this will work. All right, so you can see success. This is student 1, and I signed this. So It really isn't a very complicated exercise, but I found that it really helps to reinforce the idea of, you know, public-private key pairs and how one key, you know, the two keys work together, and then how digital signatures work. So that is pretty much the gist of that exercise. And let's just see if we have any questions at this point. So yeah, if you have any questions for the chat or any comments, just put them. You can put them in the chat. All right. So yeah, we've got a few comments. Yeah, and I know this isn't the most. I wouldn't consider this a very you know, the most technical lab, but the students found that it was fun. I'd slot it to the right audience. Obviously, if you're teaching a class in you know, advanced cryptography, that might not be, this might not be the audience for it. Is there an API? Let's see. Is there an API to implement this software in software dev? That I don't know. I'm looking into that. There is, if you look at the CyberChef page, there is you can actually download CyberChef and run it on your machine. So that is, you know, that is something I plan to look into, but I haven't gotten that far. Another question: any ideas on how this could be used in an exam? I guess it depends on how you want to use it. You could provide in an exam depending on your LMS. What I do is we use Canvas, and in the assignment I just provide a link to the key. So it would have to be an online type of exam. But yeah, you could make it part of an exam. I wouldn't see why not, and then they could submit that as, you know, if it was an online exam with, say, your LMS. Is there an advantage to downloading it, or is the web-based one good enough? I found the web-based one good enough. I really haven't honestly played around with the download version at all. So I got by fine with the web-based. Okay. So there was a question about, can I share the link? If you, Josh, are you making the slides available?
Sorry.
Josh, there was a question about the steps involved in the lab or the exercise. You are making these slides available?
Correct. Yep.
Okay.
They'll be on the
Okay.
CA community website, and so will this presentation.
Yeah. So yeah, so the information, the directions are in the they're in the presentation that'll be shared. And then once again, all you have to do to find it is just Google CyberChef. All right, any other questions? All right, okay, Josh, I think that's it.
All righty. So I just want to thank you for your time, David.
Mm-hmm.
I really appreciate you coming and, you know, sharing this with us today.